Stars in the HR diagram. How do we classify or group stars? Stars are grouped by their size, their color, and their luminosity. But there's so many stars in the universe. How can scientists compare all those stars at once? By using the Hertzsprung-Russell or HR diagram. The HR diagram tells us three things about stars. One, it tells us a star's temperature. Hot stars are on the blue side and cool stars are on the red side. Two, it tells us a star's luminosity. Luminosity just means the brightness of a star compared to the brightness of our sun. So here's our sun. It has average brightness. There's stars that are brighter than the sun, and there are stars that are dimmer than the sun. Dimmer just means not as bright. Lastly, number 3, it tells us where a star is in its life cycle. Main sequence, red giant, white dwarf, even red supergiant. Let's watch a quick video that shows stars in our universe and how they are placed on the HR diagram.
This is a Hubble Space Telescope image of the crowded core of the globular cluster Omega Centauri. The brilliant colors of the stars are real. They correspond to stellar temperatures. They can also be used to trace stellar evolution. Astronomers like to know how blue the blue stars are and how red the red stars are. So we'll first sort these stars out by color, blue on the left and red on the right. Next, we'll sort the stars according to brightness, the brightest stars at the top and the faint stars at the bottom. The final plot you see represents different stages of evolution of stars. Stars spend most of their lifetime burning on the main sequence. When the fuel starts to run out, they expand to become red giants. They find a new source of fuel, helium, and burn blue hot, but even that runs out. They end up burning out as white dwarfs. Based on images for the Hubble Space Telescope, we've assembled a true plot that is a snapshot of the life history of stars in this ancient cluster.
Now let's look at the HR diagram. Here we have a blank version of the HR diagram. We're going to talk about the labels and what you're going to find when you actually see the HR diagram. First, at the bottom, you will see temperature of stars. Notice that that temperature increases as you go left. So cooler stars are found on the right side of the diagram, and hotter stars are found on the left side of the diagram. Next, you'll see luminosity. That's brightness compared to the sun. The little 1 that you see on the graph represents the brightness of the sun. It's average, so it's in the middle. Any stars that are above that 1 line are brighter than the sun. So the brightest stars that you see are located at the top of the diagram. Any stars below the number 1 or below the sun are dimmer than the sun. So the stars that are dim and not that bright will be found towards the bottom of the diagram. The HR diagram also tells us where stars are in their life cycle. So you'll notice that stars are grouped together in these areas of the diagram. So we've gone ahead and labeled those life cycle stages here. Notice that main sequence is going to be in the middle, your red giants and supergiants towards the top, and white dwarfs will be towards the bottom. We can actually draw a line down the center of this diagram, dividing it into top and bottom. The brightest stars are going to be in the top half of the diagram. The dimmer stars, not as bright, will be in the bottom half of this diagram. If we divide the diagram into left and right, you'll notice that the stars on the left side are hot stars. Stars on the right side are cooler stars. If we continue taking this diagram and we divide it into the 4 quadrants that you see here, this top left quadrant would have stars that are both bright and hot. So some of those main sequence stars towards the top here would be considered bright and hot. In the top right-hand quadrant, you're going to have stars that are bright and cool. Remember, these are stars that are redder, like our red giants and our red supergiants. They're cool in temperature because they're red, but they're also very, very bright. So they would be located in this section of the diagram. In the bottom left, you're going to find stars that are dim and hot. They're not very bright, but they're really, really hot. In the bottom right part of the diagram, you will find stars that are dim and cool. So they're not very bright and they're not very hot. Here in the middle, typically where we find our sun, we have stars that are average. They have average brightness and average temperature. This is where we find our sun. Now, let's practice reading an HR diagram. Notice on my diagram here, I've already divided my diagram into 4 quadrants. This is the first thing you need to do when you see a picture of an HR diagram. I went ahead and wrote my labels, bright and hot in the top left, bright and cool in the top right, dim and cool in the bottom right, and dim and hot in the bottom left. So we're going to practice reading the HR diagram, and we're going to answer the questions and find the star that matches that question. All of these little dots that you see are all stars in our universe. Notice that they are different colors because of their temperature, and they're in different groups like white dwarf, main sequence, giants, and supergiants based on the stage in their life cycle. Let's jump right in. Our first question is, what type of star is the sun? Type just means where is it in its life cycle? So if we look at this diagram, you can see the sun right here. So I want to give you a second to answer this question. What type of star is the sun? Where is it in its life cycle? If you said main sequence, you are correct. Here is the sun, and notice that it is right here grouped with all the main sequence stars. Let's go to the next question. List 2 red supergiants. So the first thing I'm going to do is I'm going to find where the red stars are. That's going to be in this section, the red stars. I'm also going to find where the supergiants are. That's going to be in this section up here. So where these 2 shaded areas meet here is where we're going to find our answers. List 2 red supergiants. The first one that we see is Antares, and the second one that we see is Betelgeuse. Yes, there is a star named Betelgeuse. Sirius B is what type of star? Type just means where is it in its life cycle. So let's take a second and let's find Sirius B. Oh, there it is. So what type of star is Sirius B? If you said white dwarf, you are correct. What color star is Deneb? Let's find Deneb. There it is. What color star is Deneb? Good, white. Which star is brighter, Sirius or Vega? Remember, Brighter stars are towards the top of the diagram. So let's find these stars. There they are. They're very close to each other. So to determine which star is brighter, we're going to look to see which one is more towards the top. So, which star is brighter, Sirius or Vega? Awesome, Vega, because it's closer to the top of the diagram, so it's brighter. Which star is cooler, Sirius B or Barnard's star? Let's find these stars on the HR diagram. Remember, stars that are cooler tend to be towards the right side of the diagram. So, which of these is cooler? Barnard's star, excellent! It's cooler because it's more towards the right of the diagram. Great job! If you want a copy of these notes, go to our class teams. Click on the Files tab, click on the Week 4 folder, and open the document that says Stars in the HR Diagram Notes.